take a look at this tangent line problem. So what we have in here is we have a parametric equation. So the graph of a parametric equation is a curve, and then we have a point x comma y somewhere on the curve. So that gives you the location. What we are trying to do is I want to find the slope at that point, and then I want to use the slope to build an equation of the tangent line. So x and y only gives you the location of a point, right? But in a parametric equation, there is an t parameter t behind the x, a parameter t behind the y. So that means I can use t to describe the behavior of x, use t to describe the behavior of y. So let's see how to take the derivative. All right, so the first parametric equation, I have x. Number one, I have x equals to t to the third plus 1, and then y equals to t to the 4 plus 1, and then t is equals to -1. Let's take the derivative. So first we take the derivative with respect to t. So that is a 3t squared, and then a dy dt. That is a 4t to the third. The derivative of constant is equals to 0. Hold on, this is a t. So that will be a plus 1, and then I will use that formula, the dy dx. So the dy dx, what is that equal to? That one equals to dy dt, and then the derivative of x with respect to t, and then you have 4t to the third plus 1 divided by 3t squared. So you can still find the derivative without eliminating t. So when I consider the derivative, I can consider the t. Okay, so here they gave you that t equals to -1, right? So t equals to -1. So what's the slope? So we have a dy dx. The slope is equals to 4 times -1 to the third plus 1 divided by 3 times -1 squared. So the top is a -4 plus 1. The bottom is a 3, so -1 is my slope. So -1 is my slope. What about the 4 t to the third plus 1 divided by 3t squared? Before you plug in the t, so you have a t, right? So before you plug in the t is just a parameter. So that this one is the slope. The slope of what? The slope of the parametric curve at any point x comma y. So we have a curve, right? Look at the yellow curve. We have a curve. There are many points. So in general, how do you describe the slope of this curve? So in general, the slope of this curve can be described as 4t to the third plus 1 divided by 3t squared. Next, I want to give you a specific location when t is equals to -1, parameter equals to -1. Can you tell me the slope? So the slope is equals to -1. So that means we on that parametric curve at that point x comma y, the slope is equals to -1. But I have the slope. What about the point? So to find the point, you have to plug in -1 to the parametric equation. So we have x, right? So x is equals to -1 to the third plus 1. So that is equals to 0. And then y is equals to -1 to the 4 plus -1. So that is 1 minus 1 equals to 0. So therefore, my point is 0, 0. And then we have an equation. Okay, let's just do the math. We have a point, we have a slope. How do you build the tangent line? So the tangent line is y minus y1 equals to m times x minus x1. This is called a point slope form. In order to build a straight line, we need a point, we need a slope. So we have y minus 0 equals to slope times x minus 0. So overall, y equals to x is the equation of the tangent line. So this is the equation of the tangent line to the parametric curve at the point corresponding to t equals to -1. So that's the first problem. I still have another problem. So number 2, let's do that right now. So number 2, we have x equals to t times cosine t, y equals to t times sine t, and then t is equals to pi. So number 2, we have x equals to t times cosine t, and y is equals to t times sine t, and then t is equals to pi. So the first thing that we have to do is we have to take the derivative of x and y with respect to t. So we have a variable times, we have a function times another function. That is what rule? That is a product rule, right? Do you still remember product rule? We have f times g derivative, so that is equals to fg prime, and then what? Plus gf prime, right? Product rule. So this is equals to t times cosine t. The derivative of cosine is negative sine. And then plus cosine t. The derivative of t is equals to 1. So that is done. And then a dy dt. The derivative of sine is equals to cosine. And then plus the derivative of t is equals to 1. So there you go, you have the dx and dy, and then you apply the formula. Dy dx is equals to dy with respect to dt divided by the derivative of x with respect to t. So that is t cosine t plus sine of t divided by negative t sine t plus cosine t. So imagine that we have a parametric curve. This result is the slope of the tangent line at any point on this curve, any point. All right, and then to give me a specific point, you have to say when t is equals to pi, what is the slope equal to? So we have pi cosine pi, and then plus sine of pi divided by negative pi sine of pi, and then plus cosine of pi. So cosine of pi is equals to -1, then we have a negative pi. Sine of pi is equals to 0, and then sine of pi is 0. Cosine pi is 1, so we have actually cosine pi is -1, right? So we have a plus -1, which is a -1. So overall, pi is my slope. Is my slope at a point. At what point? I don't have any points in there. Yes, you don't have the points yet because you haven't plugged in t back to the parametric equation. So when t is equals to pi again, the parametric equation x is equals to t times cosine t, and then y is equals to t times sine of t. So that is equals to negative pi, and then sine of pi is equals to 0. So therefore, my location is negative pi comma 0. So we have a point, we have a slope, and then we build the tangent line, which is y minus y1 equals to m times x minus x1. So we have y minus 0 equals to pi times x minus negative pi. So we have y equals to pi x and then plus pi square. So this, by the way, this is called the slope-intercept form. So what is this called? This one has a name. This is called equation of the tangent line to the curve, parametric curve to the parametric curve at t equals to pi. So that is the end of this video. If you think my instruction is helpful, please like, subscribe, and share. I appreciate your help. I will see you in the next one. Signing out for now.